Okay, our last example here is an exponential equation. It's a certain structure that you're going to see in some of the problems tonight. And what I'm looking at specifically that makes it the kind of structure is a number to a power, a number to the negative power. They're being added here. They may as well be subtracted. It doesn't matter. But the key to the fact that it's this kind of problem that we're dealing with is that we have some number to a power, the exact same number to the opposite power. All right. The fact that the 2 on the bottom matches the 2, it could be a 17 on the bottom. It doesn't matter. The bottom, as long as those are both the same number. If this was 5 to the x plus 5 to the negative x over 2, it'd work the same way. All right. And the structure I have is proportional in look. All right. We got a fraction equals a number, which if I put over 1 now, it looks like a proportion. So the first thing I like to do in these problems, I like to get the fractions out of it, cross multiply. So we have a binomial expression being multiplied by 1, so it's just going to be 2 to the x plus 2 to the negative x. If this were a number like 3 halves or 3 sevenths or something like that, 7 times 2 to the x plus 7 times 2 to the negative x. Don't try and multiply. Don't make like 14 to the x. That's illegal. So 7 times 2 to the x does not equal 14 to the x. So if this was a fraction over here, just keep 2 to the x separate from any numbers multiplying by it. In this case, 1 doesn't do anything, so that doesn't happen. But it will happen in your homework. So know that that's how you handle it. All right. And if I multiply the other thing, 3 times 2 makes 6. So that's job 1. Get the fractions out of the problem. Make yourself an easier problem. Okay. Next, we'll call this the trick. All right. The trick to these problems is you don't want negative powers in your problem. You only want positive powers. It's easier. So if I were to multiply the entire thing here times 2 to the x power, a simple fact of exponents is if I take 2 to the negative x and multiply it times 2 to the positive x, that's going to get me 2 to the 0, which also equals 1, right? So it gets that negative power out of there. If I do 2 to the x times 2 to the x, the rule says I'm supposed to get 2 to the x plus x, which would be 2x, right? Right. So looking at that, if I do all that multiplication, this times this again makes 2 to the 2x power. This times this just makes 2 to the 0, which is 1. And this times this makes one of those structures I just mentioned a moment ago. It's going to be 6 times 2 to the x power. Okay. Now the last thing I want to do to make this problem workable is this. I'm going to move the 6 times 2 to the x power over to the left, and I want some descending order happening here. Descending order, it takes the highest power structure, 2x, subtract 6 times 2 to the 1x, and add the constant 1 equals 0. And what you're supposed to recognize about this is something we covered towards the end of chapter 1, which is something that's quadratic in form. If you recall, if you have ax to any power, let's say it's the 8th power, plus bx to half that power, plus c equals 0, it's a quadratic structure, right? So you have some power, half the power constant. 2x, half of 2x is 1x, and that's the constant. We have a quadratic in form structure. Now the thing that messes people up here that I want to really highlight, let me just use some different colors. I'll tell you what, if I just do an ungroup, I'll change my 2 to the x's to green, or let's go black. Make it look like a bruise, black and blue. Okay. 2 to the 2x is the variable object. 2 to the x is the variable object. That's acting like the x to the 8th, the x to the 4th here. Officially, there's a 1 being multiplied by the 2 to the 2x. There's a negative 6 being multiplied by the 2 to the x. And there's a 1 that's constant, okay? So establishing what a, b, and c are is important here. So if I'm using the quadratic formula, I know a is equal to 1, b is equal to negative 6, and c is equal to 1. I also know if I use the quadratic formula, I'm not finding out what x equals, I'm finding out what 2 to the x equals. All right, so keep that in mind. Anytime you use the quadratic formula, again, identifying a, b, and c, quadratic formula always gets us this guy here. All right, so 2 to the x equals whatever the quadratic formula returns, which if I type in the quadratic formula, enter, I got 1, negative 6, and 1. Make sure you get signs right. We get 5.8284 and 0.1716. So 5.8284 is equal to 2 to the x, and 2 to the x equals 0.1716. Right? Notice notice what we get out of that is we get two exponential equations, kind of like we saw yesterday, right?
Yeah.
We have number 2 of x power equals a number. So I'm going to log both sides. So I'm going to do ln of 2 to the x power is equal to ln of 5.8284. I move the x out in front. All right. And then so I'm going to get x just going to equal ln of 5.8284 divided by ln2. My calculator has the answer to that. I don't know if I harped on this enough yesterday when we did this, but make sure, like when you type it in ln 5.8284 in parentheses divided by ln2 in parentheses. Make sure you get that in parentheses so you don't log this divided by this and then it makes it for a mess. So 2.5431, so about 2.54. And if you do these problems right, this one should be negative 2.54.
Okay.
It should be. Because if you think about it, if x equals
If they're the
2.54,
same
this is
thing,
going to be negative 2.54, right? Right? So it should, if it's a minus sign, it doesn't do that. But when it's a plus sign, it should be opposite signs. But if we do this, then this is going to be x ln2 is equal to ln of 0.1716. Same idea. If you log both sides, this x goes out in front of the logarithm. We're going to get ln of 0.1716 divided by ln of 2. Again, hopefully it's what it should be. Ln of 0.1716 in parentheses divided by ln2 in parentheses equals negative 2.54. Notice they aren't exactly the same. I did round, so they're not going to be exactly the same, but to 2 decimal places they should be. So that's what x equals both those numbers. If x equals either one of those numbers, that is a true statement. If we try it out, if I do parentheses 2 caret 2.54 plus 2 caret negative 2.54 in parentheses divided by 2, it should equal really close to 3. 2.9939 is really close to 3. All right, so as always, when you're doing an equation, if you throw your answer back into the original problem, it should make close to a true answer if we're approximating. And on these, I would say go ahead and get me an approximate answer. This 5.8284 will be some like irrational number. You have to do ln of that. So yeah, if you want to get the irrational number and you ln of that thing over our base 2, that'd be the exact answer. I mean, just, you do quadratic formula here. Negative b plus or minus the square root of 36 minus 4 is going to be 32 over 2 times a. That'll be 6 plus or minus 2 times the square. Actually 4 times the square root of 2 over 2, which is 3 plus or minus 2 times the square root of 2. So that's 3 plus 2 times the square root of 2. That's 3 minus 2 times the square root of 2. So then if you ln both sides, so it would be log of 3 plus 2 times the square root of 2 base 2 would be the exact answer. I'm fine with an approximate answer on those. I mean, if the quadratic formula comes out to a nice pretty number like 6 or something, then go ahead and give me the exact answer. But if it's approximating, then by all means give me an approximate answer on those. That would be something on a test. If I gave you a problem with that structure on a test, I'm not going to ask for the exact answer. I'll ask for the approximate. So practicing it would not be worth your time probably, but just know it's possible to still do it, but not really as important as it would be on the other ones.